Yes.
yes,
yes. We'll take initially 4-5 minutes, then you will start your lecture.
Network problem hochi mu sir ko 3 minute time. हाँ सर.
Ratha namaskar.
नमस्कार.
नमस्कार नमस्कार
Sir.
समस्त
नमस्कार सर.
मेंबर मान को नमस्कार. पाड़ी सर को भी नमस्कार. पाड़ी सर
Dora, are you ready? Dora has some issue, I think.
Some network issue. Let him fix it.
Recording हो रहा है वीडियो तो.
Good evening, sir.
युधिष्ठिर.
Namaskar. Namaskar, sir.
Dora is there or?
No, I don't see.
No, he's trying actually.
Sir, good evening.
Singh Saab, namaskar.
Sir, namaste. Namaste.
Namaste. How are you?
Fine, fine, sir.
Fine, sir. So nice to see you.
Yes, sir. Same here, sir.
Okay. It's cold there.
It is cold, but compared to North India, it is comfortable.
Sir, am I audible now, sir?
Yes, you are perfectly audible. Shall we start?
Sir. Sure, sir. Sure, sir.
Okay. Good evening to all and namaskar. Today is our 7th edition of our fraternity presentation program. This is a program we do mainly for the dissemination of knowledge for the general public, and it is mainly done by the members and they share their expertise. So today with us is Dr. M.L. Dora, is Professor JNU, and I would now request our President, Sri Alok Bihari Panigrai, Controller of Mines, former Controller of Mines, IBM. He is our President, he is here. I will now request Mr. Panigrai to briefly outline about the Sgat as well as the today's event. Panigrai, sir.
Thank you, Jalavandovu. Good evening to all the members of SGT who are present in this fraternity presentation. This is the second fraternity presentation in this month within a period of gap of only 1 week. Nevertheless, it is a very important presentation. This is on vanadium. Now, we all know that vanadium has been declared as a critical mineral by Government of India through notification, and it is associated in India with the titaniferous magnetite. It is used, vanadium, as we all know, is used for the purpose of alloying steel, vanadium steel, and that is the primary consumption. Apart from this, in the recent years, the vanadium redox flow batteries, vanadium redox flow batteries are also being encouraged, which is perhaps the reason why Government of India has declared it as a critical mineral, because our consumption is likely to increase due to the for manufacture of this redox flow vanadium redox flow batteries. Now, in India, as on 1/4/2020, the resources of vanadium is uh, is 24.63 million tons, with an estimated B2O5 content of 64,594 tons. However, as on 1/4/2020, no reserve had been established. As all of us know, under UNFC, reserve is the mineable part of the resource. So, as on 1/4/2020, there is no reserve. But however, we find that after this declaration of critical minerals by Government of India and thrust on exploration on vanadium, the one mining lease for vanadium has been auctioned in Madhya Pradesh. And apart from that, a composite license also has been auctioned, both also in the same state of Madhya Pradesh. So, since a mining lease has been granted, a mining lease cannot be granted without a reserve. So, I think a few tons of reserve also has been established in the form of reserves. Apart from this vanadium in titaniferous magnetite, from the alumina, in the manufacture of alumina, in the process of getting red mud, the vanadium is also available in little quantity. And NALCO has completed a lab scale study to recover vanadium sludge from the various Bayer's process, in which your alumina is being recovered. Vedanta also has developed an in-house product to recover V2O5. The annual consumption of vanadium, as we gather, is around 4,600 to 5,000 tons per annum, which is likely to increase to 12,000 to 15,000 tons per annum due to the increase of steel production in 2030 by 300 million tons. This to expedite the exploration of the vanadium, Government of India also has, in general, introduced a exploration license in 2023 under the amendment of the MMDR Act, which has a very good prospect of investor, because the holder of an exploration license is entitled for share in auction value at the time of grant of ML. So this is a very welcome step by the Government of India. And with this brief on vanadium, we hope, I think Professor Dora and we are known for quite more than 15, 20 years. And we all wait to listen to Professor Dora, who is a master in this subject. Thank you very much, everybody. Now I request Mr. Jaindas to kindly take over the...
Yeah. Yes, now I would request Dr. Manoranjan Mohanty, please introduce the speaker. And before that, I would request each one of the participants, please mute your microphone, if possible, your video. And I request now Dr. Manoranjan Mohanty. And after the talk, he would be our moderator for this today's talk. So Dr. Manoranjan Mohanty, please.
Thank you, Das sir, and our President A.B. Panigrai sir. And now my turn to introduce our very distinguished guest today, Professor Muduru Lachana Dora, ML Dora. He was basically a geologist from Geological Survey of India, from our organization, and he was a very visible face, visible colleague in Geological Survey of India all over the country. As you know that because of his not only his publications, but because of his commitment and strong perseverance. For last 15 years, he has been actually, he made himself very strong in the field of geology, especially ore petrology, geochemistry, and all these things. So now Professor ML Dora, he did his MSc from Barapur University in 1995, being a topper in MSc. Then joined Geological Survey of India in 2000. Mostly worked in the central Indian Craton, especially in the Betul belt. This year hosted multi-metal mineralization, and he did his PhD on host rock characteristics, control, and genesis of copper barite mineralization in Thanevasna area, Chandrapur district, Maharashtra, under a very famous Professor K. Randive. And then onwards, he continued himself to be engaged in this ore petrology, ore geochemistry, and all. He has been honored with the National Geoscience Award. That is solo. That is single-handedly he received that award from President of India because of his discovery of PG in Heti in your Thanevasna in Chandrapur district, Maharashtra. That is in 2014. And subsequently, he has been awarded the VSSR medal from Indian Society of Applied Geochemistry, Hyderabad. And also in 2022, he has been awarded Sitaram Rumta Memorial Award, which has been instituted by our SGAT. So as you know that he is already a distinguished member of the SGAT, and he recently in December 2014, after his promotion to DYDG in GSI, he decided to leave, quit GSI and joined as professor of JNU, naturally a coveted post.
I think some issue with Dr. Mohanty's network. Maybe Dora, are you ready? Dr. Dora, are you available?
Yes, sir.
I think some problem, network problem with Dr. Mohanty.
Let me start, sir. Let me start.
Yes, please start.
You start. There is some problem with the, I don't know, there is some problem probably. Are you listening?
Right, thank you, Dr. Mohanty. Let him start.
Let him start, exactly, sir. Okay.
Right. I request everyone to unmute.
Sir, due to network fluctuations, sir, I will switch off my video, sir. Kindly permit me.
Right, carry on.
Dora.
Respected chairman, Sgat, esteemed member of Sgat and IGO, distinguished scientist and academician joined across the country. I extend my warm greeting and welcome to you all and wish you a happy new year, you and your family. At the same time, I extend my heartfelt condolence on a sad demise of our two esteemed colleagues, Satpati sir and Panda sir. I pay my respectful tribute to both of them. I extend my deep gratitude to SGAT for giving me opportunity to share my experience on a national important topic on critical mineral, especially on vanadium. As we all know, critical minerals are not merely a mineral resources. In today's geopolitical scenario, they are the power and progress of any nation. And they act as a fuel to not only green technology, but also almost all modern technology. This is the reason why the Honorable Prime Minister of India very oftenly emphasizing the importance of critical mineral for our country, for the Atmanirbhar Bharat, as well as for the Viksit Bharat of 2047. Subsequently, Ministry of Mines has interministerial consultancy has listed out 30 critical mineral, subsequently embedded to 23. Then critical mineral mission has been also has been launched in 2025 to strengthen the indigenous supply chain as well as to encourage the research in critical mineral as well as recycling and asset foreign acquiring assets and so forth. And today I will deal the vanadium, which is one of the of late, as already Panigiri sir has already briefed. Of late, it is one of the most important critical mineral.
Sir. Dora sir. Dora sir.
Why vanadium is a globally critical mineral? I request to mute. Someone is cross talking. Hello, someone is cross talking. May I request them to please mute their mobile? Today I will discuss why vanadium is a globally critical mineral and what is its geochemistry, and is vanadium substitution of a lithium, and what is the vanadium global metallogeny, and what is the role of snowball earth? Why and why not vanadium in all graphite, uranium deposit, and as well as nickel PG deposit hosted in MFE ultra complexes? And what is the Indian vanadium resource at present? As well as I will deal with Odisha case and vanadium mineral systems. Now, as we all know, the critical minerals are essential for not only for economic development and the development of technology, but for the national security purpose. They are like a today's new oil, fuel to all high-tech industries. And India has a global commitment to work on climate change in order to bring the net carbon zero emission by 2070 and target to 50% electricity from renewable energy by 2030. But 50% electricity from a renewable energy has already achieved in 2025, which was declared yesterday by our Honorable Renewable Minister Prahlad Joshi in Abu Dhabi meeting yesterday. Conventional fossil fuel based need to be replaced with renewable energy. However, the development of renewable energy is totally dependent upon the availability of the critical mineral resources. World Bank has estimated 3 billion tons of critical mineral required to decarbonize the global energy system by 2050. To fulfill this, minimum 500 times enrichment or 500 times critical mineral requirement is required. Vanadium is a critical mineral for energy transition, no doubt, but across the century, it is the only which metal remain relevant. whether it is from a first industrial revolution, played a vital role in Ford transport. Today it is a game changer in energy sectors. As we all know, vanadium is traditionally being used in essentially for stainless steel and super alloy. Nowadays, the high strength low alloy steels are being used by using the vanadium. But of late, this vanadium, after coming the vanadium redox flow battery, it is a game changer in energy sectors. Any amount of energy it can store in a liquid form that is essential for grid stability in our country. Everyone talk about EV vehicles, EV batteries, but vanadium role might have been misunderstood. Today I will discuss inside out of this vanadium, what exactly. Because of its multi-utility, globally it is almost all country has listed it as a critical mineral because of supply risk and growing demand. This vanadium possesses 4 oxidation states, +2, +3, +4, +5. Because of these multi-oxidation states, it acts as a both in a redox flow battery. It acts as a both cathode as well as the anode. The vanadium is the first. Japan is the first country which listed its critical vanadium as a critical mineral in its list in 2006. Subsequently, all countries they have revised their list. India has prepared in 2023. China is also listed as a vanadium as a critical mineral, despite China is having 60% control on vanadium. And one side, vanadium crystal abundance is 60 ppm. Other side, it has been extensively used in steel industry. That will going on. Now, the vanadium redox flow battery come into picture in energy sector, which require vanadium in a manifold. As I told, more than 50% resource is being controlled by one country, and production is almost 70%. Overall, Russia, China, South Africa, and Australia, these 4 countries control the vanadium more than 95% resources across the globe. Oh my goodness, this title is being covered up. Okay, anyhow, this vanadium lithium both are used in a energy sector, but they both have a different role in form of storage, in form of a transmission. Main lithium battery is used as a electric vehicle in a solid state, whereas a vanadium redox flow battery used in a grid scale in a liquid form. The advantage of vanadium redox flow battery is it is a non-flammable, very safe, stationary, and its long life. It more than 20 to 30,000 cycle, it will not discharge. And it is a fully recyclable even after 20 or 30 years of its life cycle. And 100% safe. Whereas lithium battery, it is ideally used in EV vehicles as well as portable electronics goods like mobile, laptop, all these things. But its life cycle is a very short, 1,000 to 3,000 cycle. And again, recycling is a very difficult and it discharges over the time. But vanadium don't have. But both they are complementing each other. Vanadium cannot substitute lithium. Lithium will not substitute vanadium, but they are complementing each other, and both are indispensable for low carbon energy future. Of late, for last 3 years, this vanadium redox flow battery's importance globally it has been realized because of its long life cycle, and any amount of energy can be stored. That is a game changer in energy sectors, and much better than lithium ion battery, which require 6 to 7 year time span. Vanadium redox battery, if it can be clubbed or can be attached with EV charging hubs, a day will come, it will be in our country, but at present we don't have. But China, Europe, Australia, South Korea, they are using this. Some countries, they are directly using vanadium redox flow battery, and some country they are connected with the solar power charging plazas, Europe and Australia. India though experimented, but in our country charging hubs are connected with the grid tied DC-AC currents. But it can be possible in a couple of years under the that vision, one earth, one family, one future vision. Recently, it is already tested in IIT Delhi, vanadium charging VRB battery connected with your charging hubs, but that is only used for a portable electronic device. And also other places, Pandit Deendayal University, Gujarat, Gandhinagar, in a larger scale, but still it is in experiment stage. Yet, India commercially, VRB batteries are not connected with any charging hubs. Once this will come, then it will be a, not only now it is playing a very important role in grid, but again a day will come that will play a very important role in charging points across, like the way we are getting petrol pumps. That is the way we will get in the future. That time is not far off. This इसको कुछ करने का उपाय है क्या? वो टाइटल सब मिस हो जाता है. आप लोग कहते हैं हाँ ठीक है then I don't have any problem. हाँ. Then there are vanadium occur in a multiple host rocks in a multiple tectonic settings. That's why understanding their genesis, process of vanadium formation is a very much essential for exploration geologists as well as equally important for mineral processing engineers. There are different types of vanadium mainly occur in form of a rather that we call it a vanadiferous titaniferous magnetites occurring in the form of a occurring in the mafic ultramafic complexes. Second type of vanadium deposits associated with shale hosted graphite associated deposit. Third type is the sandstone hosted uranium vanadiferous, that is a Colorado plateau type of deposit. Fourth is a hydrothermal one, and fifth one is a laterite type. Besides that, vanadium occurs in the places. There are few other type of deposits, but they are occurring in a minor. There are the two type deposit which dominant. That is a magmatic iron titanium vanadiferous oxide deposit, and other is shale hosted, black shale hosted, associated with graphite deposits. This I will detail discuss in subsequent slides. Due to time, I have to cover so many slides. During discussion, if situation comes, I will discuss in details. This geochemistry of vanadium is a very, very important because vanadium possesses 4 oxidation states, V2, V3, V4, V5, whereas V2 is a very rarely occur. It occurs in extreme reducing condition, which rarely occur. Otherwise, vanadium occur in V3, V4, V5. And V3 is in reducing state, V5 is in oxidation state, V4 is in transition. And this fix in silicate, or it will fix in sulfide, or it fix in oxides. But always vanadium prefer to partition in oxide minerals under ambient redox condition. The vanadium don't have any independent minerals. Vanadium always associated, rather replace in the traces in the lattice of the other minerals. That is the reason why the maximum vanadium percentage in a rock, in a bulk rock, is maximum up to 3%. We won't go because it cannot 100% substitute in even iron minerals. It substitute up to some level, and it occur either by isomorphic substitution or by adsorption or simply absorption. There are different geochemical ways vanadium will attach with the minerals. Accordingly, the vanadium deposits types are decided. The right side BS image it is from a vanadiferous titaniferous magnetite type deposit. There are 3 different colors. The light color is magnetite, the little bit dark is ilmenite, occur as exolution within magnetite. Here, vanadium occurring in a V3 state in a under a reducing condition. It is already there. If we analyze magnetite by EPMA, we will come to know that vanadium is there some portion. Once it is oxidized by hydrothermal fluids, then vanadium released from the magnetites. Then that time vanadium will act as a V5, that is oxidized. When it is oxidized, it is a mobile and it is soluble. Then it will go along the fractures. The moment it will come across some reducing agent like methane or some Mg rich minerals like a Mg chloride or some other like epidote type things, it will come. Then it will start get precipitated there in the form of again V3. It will move in the form of a V5, but it will precipitate again in the form of V3. The second image, the dark portion is a little bit in FCC image it is being showing. It was there in magnetite. This is the concept in a grain scale, but this concept is applicable for a deposit in a regional scale also. Then vanadium is remobilized through this grain and will precipitate here. This blue color is your vanadium garnet, that is your gold manite, and the remaining vanadium has redistributed along this deep green, that is called chloride, that is called mucinite. This is a remobilized part. The concept is V3, V5. One is reducing, other is oxidizing. And the formation of vanadium, the metallogeny depend upon multiple factors: source, processes, redox conditions, oxygen fugacity, and tectonic setting. Source means basically mantle should come from mantle, then it will lead to your VTM type of deposit. If source is your marine, that will lead to your black cell or graphite type deposits. Process in a magmatic setting, a late stage magmatic differentiation process will be act, where this vanadium will precipitate along with magnetite, ilmenite, or a fraternite. In a sedimentary type, diagenesis, first sedimentary marine sediments undergo diagenesis process, then subsequent metamorphism, then followed by hydrothermal process. Then only the vanadium will form in a graphite associated, your black cell associated graphite deposits. In all type of wall deposits, this oxygen fugacity dictates the valency safety. Oxygen fugacity is the most important in understanding vanadium metallogeny. In a VTM type deposit, oxygen fugacity is very low. During ultramafic rock, when pyroxene olivine precipitate, that time vanadium is in V3 states, but because of extreme low reducing condition, V3 won't go with neither with olivine nor with silicate, other pyroxene, nor with the sulfides, nor with even very little with your chromite. That the precipitate, because of this oxygen fugacity is low. Once the oxygen fugacity will be moderate, then this V3 will shift it to V4. That time it is a compatible, and V3 will enter. That time your ilmenite magnetite saturation will take place in the system, and that is why the partition of ultramafic rock to mafic rock, when this chloride gabbronosite starts, that time this magnetite layers comes in pictures. That time this V3 and V4 enter. V5 is only during Vandet, that is during highly oxidized environment, V5 will form. And the tectonic setting is also very important role. Vanadium won't form in almost all tectonic settings. The preferable tectonic setting is that is a rift setting, where in a rift setting, the magma is forms in a moderate oxygen fugacity condition. That's why it is preferable, and during that condition, your iron titanium they favorably forms, and vanadium required those minerals to accommodate this. That is the reason why in a arc magma or in a subduction related magma, the fluid is a little bit highly oxidized. That's why it won't prefer to go there. In a Bastar craton along the margin of the eastern Dharwar, margin of the your EGMB, Eastern Ghat mobile belt, beautifully Rohit Pandey and Chalpati Rao Sahab have reported how beautifully your vanadium is even in a grain scale occurring in a complex are formed. But in a mafic in a late mafic complex at a late stage, late magmatic differentiation time, your gabbro anorthosite form. That time, vanadium is a preferable time and place. That is a partition. Then questions come: why not? Almost all mafic ultramafic complex are not associated with vanadium deposit, because the oxygen fugacity dictates the things. The right side is a litholog of all non-layered complexes. Busbelt complex in South Africa, your Windmere complex in Australia, Lagdere and Bell complexes in Canada, and your Fanjua complex in China. Apart from this extreme two, which is a Busbelt and Windmere, they are the sensitive to layered mafic ultramafic complex. The upper part only the vanadium precipitate, I told the region, because there only the magnetite layers come into picture. That is the reason why. Generally, it won't go with the down part, that is ultramafic rocks, initially ultramafic rock, which generally forms nickel PG mineralization, and that under reducing condition. The topmost is the oxides they are forming in a moderate oxidized condition. Moderate oxidized condition is required for vanadium precipitate in these systems. Coming to Indian picture, in India there are so many mafic ultramafic complex has been mapped by GSI, and but almost all complexes they are not sensitive to layered complex. Some are mafic, some are layered complex. In a mafic, there is a chance to get vanadium compared to layered complex. In a layered complex, only you will get in the upper part, not in the bottom part. Bottom part is good for nickel and PG, not for the vanadium. The sampling in this situation, sampling play very vital roles. You cannot sample the same sample won't give the PG value, won't give the nickel. When it will give nickel PG value, you don't give the vanadium value. Means I have seen so many papers results I matched, but it is not correlating. The reason is because that the oxygen fugacity and the redox state of your vanadium. This is the anorthosite, and the topmost is the magnetite layers. In anorthosites also, in dissemination you will get magnetites. There also vanadium you will come across, and the magnetite layers that is full of vanadium. Maximum you may come across 2 to 3% vanadium. And the right side, though it is a cycling process, anorthosite, chrome layer, chromatite, then peridotite, then dunite, like that, it is a cycling process. But in a chromatite layer, you will get vanadium, not of the economic importance. You will get less, but not the way magnetite will accommodate. Here it will not take. Why? Because in chromite, the iron's oxidation state and this magnetite oxidation states are even their size is also not mismatch. That's why it hardly enter. The same case in hematite, vanadium won't enter so easily compared to magnetite, because hematites ionic radii and vanadium ionic radii, they are both are different. That's why it prefer magnetite, not hematite. Otherwise, almost in all iron ore deposit would have been got vanadium. That is not the case. Then vanadium, uranium, graphite, they all are one common factor, that they all are redox controlled mineral and very sensitive to redox state. And they share common geological environment and say common physicochemical conditions and formed by same metamorphic hydrothermal process. But graphite deposit, not one graphite deposit. Graphite deposit formed by metamorphic process, formed by sedimentary process, formed by even sometimes by magmatic hydrothermal process. Only the metamorphic formed graphite deposit, they share common relation with the vanadium, not other two. In igneous systems, in igneous type, they don't form vanadium in a graphite, though they are less types, but not frequently occur. This metamorphic play very vital role in a graphite, but in extreme granulate condition case, this vanadium and the carbon, they decouple it. Vanadium will go out of the systems. But the vanadium and the uranium in a Colorado plateau type deposit, they remobilized from the initial sandstone. They occur in the form of a redistribution enrichment, supergene enrichment over the top part. That is in form of a Vandite or a carnotite type uranium mineral, uranium vanadium type minerals. And one case simple example from a Betul where I worked out during COVID time with my team. We have noticed uraniums, apatites, as well as amphiboles. Here, vanadium will prefer to go with amphibole as well with apatite because vanadium always prefer to go with phosphate. Preference is magnetite, then second is sulfide, third is silicate, the fourth is phosphate. Even phosphate is there, it will go with phosphate. Then here apatite is a phosphate, so it will go with apatite. Even we have analyzed EPMA and we have seen some quantity of vanadium is there. Unless you know where vanadium is according to which mineral, it is very difficult to do during mineral processing time. You will get 3,000, 4,000, sometimes 8,000 vanadium ppm, but you won't get any vanadium minerals. Then where vanadium is accommodating? We need to know these things from petrography as well as EPM studies. Many of time, vanadium and graphite, they don't, even many graphite deposits don't contain vanadium. Why so? The classic example is your Rajasthan graphite deposit. In some graphite deposits of Odisha, some graphite deposit of southern granites. Even Sri Lanka, beautiful graphite deposits are there, but they don't contain any vanadium because those are formed in a extreme conditions where this redox condition won't support and moreover the Sri Lankan graphite, they are hydrothermal types. Under extreme oxidized condition, vanadium will be V5. Otherwise, in V3, it is very difficult. They are immobile. The hydrothermal fluid is very difficult to transport V3. That's the reason why we won't get Sri Lankan graphite and in many graphite deposits. But we get graphite with vanadium enriched like a Betul belt. Some are in along the CITZ because they have not undergone extreme high temperature metamorphism and moderate oxygen fugacity. That is the reason why we used to get 6,000, 7,000 vanadium very commonly. Like I will discuss the another case study also why their graphite and both vanadium used to get very frequently. And same is a case applicable for the uranium and vanadium. Though they are reducing sensitive, though both are minerals, but not almost all uranium deposits are contain vanadium because vanadium occur in extreme reducing environment and uranium occur in extreme oxidized environment. Extreme oxidizing, both extremes are not good for vanadium. It's a very sensitive. Uranium can precipitate, but vanadium won't precipitate in the system. And again, the pH, EH again also control. One control acidic, other is not that much acidic. And source rock control also. There are so many things. One classic example of I was going through literature, Rajasthan graphite deposits. Recently, a huge graphite deposit has been discovered by Geological Survey of India in Rajasthan. But there, vanadium is a very low because in a protolith, vanadium is not present in the meta sediment. Earlier, it was not there. So vanadium won't. If it is there, then it will enrich during this subsequent metamorphic and subsequent process. Then geological potential is concerned India, though it is from Geoscience Australia in 2019 data. That time, Indian geological potential is low, but low is a concern with respect to Tritium, that is a vanadiferous retiniferous magnetite. But when now in our country emerging resource vanadium is concerned is a secondary, that is a black cell hosted or graphite associated. But now it is coming all along the Himalayan belt and CITZ, along the CITZ. So when our country geological potential for PG can be moderate and graphite can be moderate, then vanadium is also better than moderate. If we will take the Arunachal cases and other Himalayan cases, I will deal with in subsequent slide. It is a moderate. Now in India, we are getting VTM type, graphite associated uranium vanadium type, laterite type. VTM types long back in 70s, I think Vasudev Saab, Srinivas has mapped in Nagyal schist belt in Dharwarkatan. They have reported PK Banerjee and associates. They have reported vanadium from your Singhbum Craton, especially in Odisha part, and from other places. many people have worked, they have reported VTM types. But graphite associated, now it is emerging. It was not earlier, only we used it to analyze only graphite, but we never use it to analyze any vanadium. Now we are getting 6,000, 7,000 ppm. So we are analyzing every graphite deposit, but every graphite deposit we won't get vanadium. Now again, the laterite. This is another emerging area where you will get laterite. I will deal kept one slide there. In subsequent slide, I will deal how laterite over Deccan Trough, laterite over mafic rock, laterite over ultramafic rocks, which will be the best for, and laterite over alkaline complex like your Soong Valley carbonated complex and Assam Jarsura carbonated complex. There, how vanadium we are getting high. I will discuss, because one slide I have kept, in subsequent slide I will discuss. Though the BTM type geological potential is very good, but they are like a very small plugs. They are like a dismembered mafic ultramafic complex. They are occurring as a small bodies. So they are not. We are not getting any large mafic ultramafic complex like elsewhere in the bush belt or in Australia or in Canada. Here, our mafic ultramafic complex itself is a very less. So BTM types, they are only intrusive types and Lansodale types. So we are getting less resource. But the sedimentary, meta sedimentary type, like the whether it is whether it is a Arunachal Pradesh or it is a Betul graphite deposit, they are the huge kilometers together, 15 kilometers, 20 kilometers band is going on continuously, thickness of 10 to 50 meters. They are on the shear zones, pinched, but not far apart, pinch and swelling, but continuity is there. So a vast amount of resource one can estimate. If laterite will come, then it will add a flavor to the vanadium exploration in our country. The three things, irrespective of deposits, oxygen fugacity, oxidation state, and host rocks, these three things will decide the fate of the vanadium exploration in our country. Then, how the vanadium formed, vanadium metallogeny, the global vanadium metallogeny. The global, because vanadium is a oxygen controlled minerals, rather metals. It evolved along the Earth oxygen cycles and over the times. This great oxidation event has occurred around 2,200 million years ago. Subsequently, the vanadium started precipitated in the systems. And during the 2000 time period, many graphite deposits are associated with vanadium they formed. One classic example is your Betul graphite deposit. It is also a huge deposit, though maximum only less than 10 part we have explored. Maximum part is in the reserve forest. Still, it is 100-meter thickness. One bands there 100-meter thickness. And during the Neopatricic time, snowball earth come into picture during 720 to 635. This is the period where the vanadium, the fertile period in the earth time scale. Because of this snowball earth, after the deglaciation, lot of sediments has supplied to oceans, as well as the ocean water is enriched with nutrients and rich organics has developed. And whatever the oxide minerals were there in marine sediments, they scavenged this vanadium from this ocean water. And under euxinic basin, on a euxinic condition, because that is euxin means absence of oxygen and presence of sulfur. That is euxinic condition. Vanadium enrichment has been taken place. This is the reason why how the extreme side they are showing the peak all over the world. The big deposits they are formed during the Fenrozoic time. That is during snowball earth. This is the global perspective of snowball earth. You see, 630 to 700 during this period. Very big deposits across the globe they formed, but we have not find any such deposit in our country. But interestingly, this is the time our intercontinental sedimentary basins, the upper part of the intercontinental sedimentary basin, whether it is Vindhyan or Kadapa or it is Kalandagi or it is or other your Marwar basin, all the time scale is matching. So we have to really relook in that angle. During this one, China, 55 billion ton ore has formed vanadium with 1.2% vanadium ore is formed. That is 55,000 million ton. Such a big deposit. That is a popularly known as stone coal deposit in China. That is neither a pure coal nor it is a black shell. It is in between. But one deposit is such a huge. During this snowball earth time, there are many deposits, even Sudan, 1 billion ton, 2 billion ton. There are so many 2 billion ton deposits are formed across the globe. But in our country, yet we have not reported such thing. As I told in there, the time scale is matching. Almost all our intercontinental protozoic basins, they are matching time scale. We have to look in that angle whether any such or from a black shell, we need to do again resurvey. I was going through one literature, George 2017, a PRL publication. They have reported, they have hinted at, but not analyzed much analysis. So it's very difficult to predict any or rather interpret on that limited data. Now the emerging vanadium graphite resource in our country is that is Itanagar belt, which is around 150 kilometers in a Khathabari formation, controlled by highly, it's almost controlled by shear zone, where more than some 9 to 10 blocks where GSA has done extensive work and estimated the resource. Almost all, I think 6 to 7 block has been already auctioned, and very good graphite resource with vanadium, around vanadium 5,000 to 8,000 ppm vanadium. At places, it is up to 1% vanadium has been reported. And it is along with carbonaceous phyllite. But apart from carbonaceous phyllite, there are places where vanadium is associated with phosphate. But those were yet not carried out, but their occurrence has been reported in literature. So those places we need to revisit and to carry out the vanadium survey. Apart from the Itanagar site, the other places in along the Himalaya, whether it is a Nigaldhar syncline in Himachal Pradesh, or it is a Krol in Uttarakhand, or it is a Uri sector in Jammu, where in year 1890 it was reported by one Middlemoss, means CS Middlemoss, 400-meter thickness graphite deposits with vanadium. During that period, is maybe 130 years back. If it is 400 and it is in along the Himalaya, so it will not easily pinch it out. These are the huge, I don't know, but these are sensitive place. Means I didn't get much information, but they are there. So along the Himalaya, these are the emerging belt, the black shell. They contains graphite as well as they contain the vanadium. This is the emerging area we need to. And the second emerging area is the laterite. Laterite, as our country is a tropical country, we do get huge lateritization along Western Ghats, along the Eastern Ghats, Central India, or along the northeast part. But along the Western Ghats, they developed over the mafic ultramafic plugs. If it is above the mafic ultramafic plugs, or if it is above the Deccan Tribe, then definitely there is a chance we will come across very good quantity of vanadium resource. During in 2021-22, State Unit Hyderabad, State Unit Telangana has taken 1 or 2 items. It is an area called Vikarabad in and around Hyderabad. It was an idea of Janardhan Prasad Saab to propose, and more than 6,000 ppm vanadium is occurring along with the laterite. And that laterite is developed over the Deccan Tribe. Deccan Tribe, if laterite developed over Deccan Tribe, you will get it. If those areas are pickrite, then we won't get. They are the MG rich basalt. MG rich basalt, we won't expect any vanadium. Only the iron rich tholeidic type basalt, we may get a chance. And this part is the Odisha, where the maximum your laterite has developed over your khandalites and all. Those we don't expect, but over the mafic complexes like Badam Pahar and your Nuasai, all these things, there we may get very good quantity of vanadium. And the northeastern region, there is a huge chance because these are alkali gabbros. In alkali gabbro, titanium magnetites, they are commonly present, and those are the minerals, host mineral for the vanadium. Compared to all, this northeastern part is more prone in laterite. The vanadium is also reported from the placers, west coast, not the east coast. East coast, we don't get conducive host rock for getting placers, but we do get monazites and other rare earth minerals, but not vanadium. In the west coast, ilmenite and magnetites. As I told, vanadium preferable to go with magnetite rather than ilmenite because of its charge valency and all, other ionic charge as well as radius. But in the west coast side, we get vanadium up to in a magnetite up to 4,000 ppm. In ilmenite up to 2,000 ppm. GSI has estimated the carried out the survey, estimated some resources, and published published by I think GS officer has published. Now coming to the picture of Odisha, which is one of the most mineral rich state in our country, favorable geological condition, almost all rocks, almost means Archean rocks, petrozoic rocks. One side is a Bastar Cutton, other side is Singhbhum Cutton. Both cuttons they are favorably both cutton. The mafic ultramafic rocks are intruded, and those rocks are very conducive for the vanadium mineralization. And whether it is a Nuasai complex or it's a Moorbanj Badam Pad or it is a Sukinda. Only thing is that if laterite is developed over ultramafic rock, I think there is a less chance to get. Or if it is over the mafic rock, there is a means good chance. Graphites, very good. Odisha is known for graphite, but here graphite is not that much enriched with vanadium because of this oxygen fugacity might have not favoring, and moreover the graphites are developed over the khandalites, and khandalites itself is not having any protolith mineral like magnetites. They are poor in that, and the sediments itself is not having any vanadium previously. That's why it's not that much rich as compared to your Itanagar or Central Indian graphite deposits. But India is means Odisha is having one means good thing is that huge red mods, red mods, red mods, and where there is a chance to get vanadium, good quantity of vanadium around 1,000 to 1,500 ppm vanadium. I will discuss in detail here. I was discussing Manranjan Mohanty sir, who is supposed to be he is rather the first day when I joined GSI, he is my mentor. Till today, he is my mentor. So I used to, with Mohanty sir, Ras sir or Nanda sir, I used to frequently discuss with them about this regarding this mineralization. Sir has a one suggestion, how this NGCM of our NGCM anomaly over this plateaus, that called what bauxites, where this Odisha, where we used to get on Damanjodi, how it behaves. Sir, vanadium always associated with sir irons. So wherever the iron titanium anomaly will show, no, sir, there we assume that vanadium must be there. As such, when iron is dominant, vanadium will be subdued, sir. There it is very difficult to, sir, get as such an independent vanadium anomaly. We will get in form of iron or a titanium. There we need to, sir, do further detailed resolution survey. Then only we can do it. But in this NGCM, in a large scale, sir, sampling, it is very difficult to. It was one sir suggestion I have attended. And why this vanadium exploration is a challenging one? Because as it don't have any independent minerals, it's one difficulty is one side. Because it's low grade, and wherever the vanadium occur, whether it is a VTM or it is with graphites, they occur along the discontinuous patches. So if it is a discontinuous structurally disturbed, and almost all graphite deposit where vanadium is associated, they all are structurally controlled. And it is very difficult to estimate the resource accurately. And because of diverse host lithology and metamorphic overprint, and some of the geochemical ratios, they are there. They are the pathfinder for vanadium exploration. If it is not highly disturbed by metamorphic overprint or subsequent hydrothermal disturbance, high VT should be value in form 0.202 to 0.03. It is valued for Btium, and vanadium chromium is better than should 2. These are the experimentally proven, and these are the we cannot call it the thumb rules, but these are the definitely they are the guiding factors one can yeah. Because of these low bands and low lensodal natures, geophysical survey also poorly responds. That is one limitation. And snowball earth effect and the sedimentary basins upper part of the systematic mapping, yet data I didn't come across, so I can't comment on, but these are the places we need to revisit. As per my experience, because I'm not a sedimentologist, I have not worked much in sedimentary basin, so I cannot comment on that. But as elsewhere we are getting, so I hope that we should also get. No specific mineral system framework exploration. Generally, when we do graphite exploration, we get vanadium. When we do nickel PG exploration, we get vanadium. As such, no dedicated vanadium exploration, but nowadays GSI is aggressively doing vanadium separate items. Earlier, during my time, we always use it as a co-product or a byproduct type of exploration. One thing, mineral system approach is very much required for vanadium exploration. Otherwise, we won't get. Why vanadium? Because vanadium controlled in a different diverse host rock. Sometimes it is a mafic rock, sometimes it is a graphitic schist, sometimes it is a shale, sometimes it is a carbonate, sometimes irrespective of rock it is getting. Unless we use the mineral system approach. Mineral system approach means the geological process which starts from a source up to last preservation. The chain of sequence, how it is involved, how this melt has come, how it has transported, then where it trapped, what geochemical parameters prevailed there to trap, then how it is preserved. Entire mechanism we need to carry out. It is like a footprint, the ultrasound footprint mapping we need to carry out. Once you know the footprints, it is difficult to catch all the deposits in a distal place. That is the way we have to mold ourselves being exploration geologists. We need and rather we must do vanadium exploration, especially using mineral system approach. Then only there is a chance to get. Otherwise, it is very difficult. And apart from primary, now vanadium secondary source is a very important. Why? In our country, there are so many things are there. Developing mines, it requires some times. But now India is market is electronic market is so fast. Manufacturing sector is so fast, and this critical mineral, maximum critical, we depend on imports. So in order to bridge that gap, we need to develop mineral processing techniques rigorously and aggressively to take out to separate the vanadium from red mud from a steel industrial slags. Though from red mud, Indalco is doing through this after Bayer process, the Indalco is doing, but the red mud vanadium proportionately they are very less. The maximum part vanadium lies between two. One is a coal fly ash, other is a steel industry. Both we are good in our country, so we have to look for this. This is another domain where we need to work out. And this is also as one of the objective of national critical mineral mission to recycling from the secondary source from a mine dumps and from the spent industry catalyst. And another places vanadium, that is refining petroleum refining products. There we will get the vanadium. The secondary sources is also important. We cannot, because vanadium from a ground to develop a mines, it will take a time. But from a waste, within a few years, we can develop if we can develop the mineral processing technique. Another is important is red mud. In a red mud, we should know how red mud is a waste product after the aluminum extraction from a bauxite ore. But what this red mud is all about? This is nothing but iron rich, alumina rich, highly alkali rich product. Then what is its vanadium content? This red mud contains not only vanadium, there are other important critical minerals, scandium, gallium, chromium, nickel, almost all critical minerals associated with red mud in a very good concentration, around vanadium 2000 ppm, even Re 1500 ppm. More than that, scandium is very important. 150 is also very important, scandium. They all are associated with, but because of this, they are in highly alkali rich muds. Now, processing techniques in our country, I am though I think they are doing, but it need to do in a large scale. I have scanned some literature. Very good things are there. China has been doing. Uh, Initially, they followed the acid leaching. Now they are following the organic organic process to extract how, because this vanadium is in the lattice form. It's a tough job for a mineral processing engineer, not that easy. But mineral my what is my perception that a mineral processing engineer should closely work with a exploration come a petrologist. Unless you know where the vanadium lies, which phase, whether it's silicate, oxide, or sulfide, or a phosphate, or somewhere, that type of things, very thorough study is required. Aggressively XRD studies followed by SCM and EPMA, these three combinations are very much required, along with petrography. Then these are the some of the flow sheets for VDM has developed, and traditionally methods we are being following for extracting the vanadium from a ore. But uh, uh, I think this is the where midstream processing is the biggest challenge at present in our country. This needs to be strengthened. Then it will be immediately helpful in a secondary source. Then subsequent we can come to primary deposits. But secondary source are the huge steel slugs, huge fly ash are there. We will get plenty of vanadium along with other critical minerals. This is the last slide. I will come to. Then what is the best global practices for vanadium exploration? There are three axes: exploration, analysis, beneficiation. Three axes need to be equally treated. Exploration, as I told, mineral system approach is very much required. Analysis is concerned in our country, as per my knowledge goes, we do analysis by XRFs for speedy analysis, all these things. But vanadium, it can be analyzed by XRF, can be analyzed by ICP-MS, it can be analyzed by ICP-OES. The best method is total digestion by ICP-MS. That need to be. If you do XRF with black cell hosted graphite hosted sediments, the result will not good. It may give some good result when it is with VTM, but not with black cell. But how chemist will know that it is from a black cell? Once we will give the samples, it is very difficult. They go with the SOP. So we need to specify which type of samples need which type of methods treatment. Even laterite also, we cannot analyze by XRF. We need to go by ICP-MS. And the beneficiation I told, though as per my basic knowledge goes, in our country, advanced microwave, plasma-assisted AI sensor techniques, they are, I think, in a experiment stage or in a research stage still. It is not yet commercially, but these need to be aggressively required for understanding critical mineral. Why so? Because critical mineral as such, out of these 23 critical mineral, more than 15 critical minerals, they don't occur as any minerals. They always occur in the in the other mineral in lattice. So unless we recover, we know the technique how to recover from the lattice, then it is very difficult. This is all about. I must thank Minister of Mines for encouraging me to carry out research on vanadium, as well as the ARF, A Energy, DST also has funded me to carry out research on critical minerals. Obviously, my mother organization GSI always stand like a backbone, and of course my present organization JNU, that is supporting me to carry out, encouraging me to do research on critical mineral. Sgat is always, all my mentors are from Sgat. They are always like a working like a shadow. And thank you everyone for your patience listening. Any questions? Because of network, I was not in a flow. Somehow I couldn't, the way I generally speaks, I couldn't speak because of fluctuation network. Video is not coming little bit. I'm sorry for that. I would love to discuss any queries, please.
Thank you, Professor Dora. It's certainly an excellent talk, virtually touching upon all aspects of vanadium, a little known subject so far as India is concerned. I once again request all our esteemed audience, the members, to kindly put your questions in the chat box so that it will be easier for Professor Dora to answer, and it will be good for interactions. So first of all, I am seeing one discussion by Muzaffar. He has asked, he has actually worked in the Salkalas of Jammu Kashmir, where small bands of graphite cyst is present, but the V values are not encouraging. What is the probable cause, Professor Dora?
Pardon, sir. One
He,
second, sir. Please, sir. Please.
Muzaffar is asking, he had worked in the Salkalas of Jammu Kashmir, where small graphite bands are present, but without any vanadium being reported there. What could be the cause of absence of the vanadium in the graphite there in the Salkalas?
Sir, as I told during my presentation, all graphite deposits don't contain vanadium. In the Jammu and Kashmir case, we need to, sir, there the highly orogenic belt, Himalayan tectonics play might have role. There, we need to see what are the mineral phases present in that graphite. Is there any oxides minerals are there, or any mica minerals are there? Some minerals, taker minerals should be there, like ilmenite or a rutile or a magnetite. If it is not there, then some muscovite should be there, because as such vanadium don't adsorb by graphite itself. Though those minerals they associated with the graphite, that is why graphite deposit shows the vanadium concentration. But as such, graphite don't absorb any vanadium. But if clay minerals are there, they will absorb the vanadium, not graphite. That may be the one of the reason the associated host mineral might missing there.
Thank
But
you.
which part they are also sampling. They need to do some petrography from SCM.
Yes.
They need to first identify the assemblage. Once they identify the assemblage, then what is the missing cause, they will know themselves, sir.
Then one Yudhishthir, he is asking about the VTM deposits in Meghalaya and Assam, particularly in Karbi Anglong district. There are small bands of your vanadiferous identifiers magnetic bodies. Has it been any substantial vanadium being reported there, or any work being
Sir,
done? Do you have any
yes, sir.
Karbi
In
Anglong
Meghalaya,
district in Meghalaya, Assam?
in Meghalaya, Rambari area, West Khasi Hill, where vanadium is reported even up to 8,000 ppm. One of my ex-GSI colleague, Dr. Ravi Umrao, now also he is my colleague at JNU. He has reported, he has published in geology review along with Mohammed Sadiq. They have reported value up to 7,000, 8,000 ppm in a BTMs. Huge BTMs are there.
Okay. Next, one more. Girija Mahapatra Sahib is asking, thanks, Dr. Dora, for the excellent presentation. Can we expect vanadium in the placer minerals, particularly pyrope garnet? Is there any chance of getting vanadium there?
The garnet, we won't, in a garnet, vanadium will go with garnet. There is no doubt. If magnetite is not there, if other minerals are not there, then vanadium will enter. But extreme metamorphic condition, vanadium will not go with garnet. But in garnet, that's why gold manite, vanadium we are in garnet. Vanadium go with tourmaline. Vanadium go with other minerals. But we do get garnet as a placers along the east coast, not along the west coast. Along the east coast, the source rock for the garnet is your, sir, host rock is garnet, your khondalites. In a khondalites itself, vanadium was not that much enriched. So, sir, how it will come to vanadium? in a garnet. So there is a less chance.
Thank you. Actually, my small interruption here. Professor Dora, can you just tell me what is the cutoff? Cutoff in the sense, what is the benchmark value by which actually you should go for vanadium expectation? That means, what is the ppm level vanadium after which you should now target that particular rock having vanadium resources and all? What is in
Sir,
India? What is
cutoff
the
depend upon.
assumption?
Yes, sir. Thank you, sir. Very nice question. Cutoff depend upon the market. Yeah. Till yesterday, sir, we never realized that vanadium importance so much in VRB, vanadium redox flow battery. Now it is aggressively VRB demand is so high. So definitely, sir, cutoff value will be less. So anything in a VTM, we will get around 3000 ppm is good enough.
Okay. The same question, Manil Kumar from Gemfields is asking vanadium with 600 ppm. Will you have any feasible mining benefits if a deposit host rock is more than 20 million ton?
Then, sir, then they need to do, sir, beneficiation, and then that 600 ppm also where it is accommodated. Sir,
Yes.
from a vanadium, if it is associated with a silicate, it is very difficult to extract. If it is associated with oxides, it is it's little bit easy compared to silicate during mineral processing. So that even that 600 ppm, which mineral it is accommodating, that need to know first.
Yes, exactly. So there are a lot of appreciations by many senior colleagues. Dr. Raman is appreciating everyone. Excellent information and presentation by Professor Dora. Nathan Sahab is also highly appreciative about it. Excellent presentation, Professor Dora.
He is another guru, sir, who has
Ah,
taught
yes,
me
yes, busy guru. Yes,
Mafic.
I know.
He is another guru who
Busy.
has taught me initial Mafic, ultra Mafic.
Yes, yes,
Especially,
sir.
I learned
Please.
how to do PG. The PG vanadium, they are the two opposite spectrum, two
Yes,
opposite end
exactly.
of one spectrum.
Exactly.
This is the
That's
down below, that is the up one.
K. Satish is also writing.
Excuse me, sir. Excuse me.
Yes.
Moti sir.
Yes, sir.
Just,
Nathan sir. Yes.
just the later part of the my comments, I just asked clarification from Professor Dora sir. How he has mentioned the coal fly ash contains vanadium. 30% of the resources is quoting coal fly ash.
Yes,
In
targeting.
that aspect, I just want to know from the because in South we are mostly having thermal plants based on lignite in Neyveli and other places. So whether
Yes.
any data is available for vanadium presence in that fly ash? Dora sir, can you throw some light?
Actually, sir, vanadium is always go with organic content. As a sir, coal associated with the carbonaceous phyllite, coal of lignite, South Indian coal lignite, sir, I have not seen. But as for the sir, Singrauli and
Singrauli.
Singrauli coal field, sir, one paper I have seen it. It is there, sir. It is there,
Okay, sir.
and moreover, the coal field of Central India, though, sir, we have attempted, but we have yet not published. But good vanadium quantity is there, sir, in settled in coal fields.
Thank you, sir. Thank
Maybe
you, Dora sir. Very,
I need
very
to
nice.
sir, work on that. But very good question, sir.
Thank you, Dora sir. Keep it up. Very good. Excellent presentation.
Sir,
Thank you,
this is
sir.
Abhishek Shukla from JSI, sir.
Yes, I've got
please.
some more questions in the chat box. Let me. Khitisra is asking. is asking, what is the prospect of vanadium in the Badampad Gurumuchani? I feel that he has already dealt upon it, but again, Professor Dora, just clarify. Gurumuchani
Pardon?
Badampad.
Badampad, sir. I didn't come much literature because of sir. I didn't come, but sir, sorry, sir. I didn't come much literature. Though it was a suggestion, but I couldn't attend because of my 11th hour year. But I was going through Professor Banerjee one old paper, but as such, vanadium values around 3000 ppm, sir, in paper
Yes.
of 84 chemical geology it is published. If I remembered, but is latest paper by the sir paper as Nanda sir was suggesting, but I didn't go through those papers, so it is very difficult to pinpoint the exactly what is the exact value. But PK Banerjee sir paper I have once I read it, I think around 3000 to 4000 ppm, but exactly, sir, I am sorry, sir, exact number I have not remembered, sir.
Sir, I want to add one point.
Lot of okay, Dinesh, I'm just coming. There are lot many appreciative charts are there from many
Okay,
senior
sir.
people.
Acha, Dr. Mohanty, there are
Yes.
some questions in the YouTube also.
Acha, okay, okay. How can you please see that?
Acha,
No, before that,
no, I can ask Dr. Dora.
no, before that, let's give Dinesh one chance before going to
Right.
the YouTube. I think Dinesh,
Okay,
please
okay, sir.
make it short.
Sir, okay, sir. I am Dinesh, former director GSI. Now I am with Geomarine Solutions Private Limited. Professor Dora, excellent presentation, very informative. He was my colleague and friend. I would like to add here our experience, two unusual behavior of vanadium. One is from Karnataka. There is no mafic, ultramafic rocks over which the laterite has been formed. It is formed above gneisses. We have estimated G3 resource about 25,000 metric tons of V2O5. So that is an unusual behavior. There is no mafic, ultramafic nearby. Next one is there are ilmenites in the beach sand of Kerala. Along the Kerala coast and offshore of Kerala also. There it is estimated 0.14 to 0.18% within the ilmenite. There is no magnetite there. It is formed from, it has come out from charnokites and condonites. So these are two unusual, and I feel the most untapped resource of vanadium is in the beach sand of along the Gujarat coast and Maharashtra coast. We also estimated around 18,000 tons and 6,000 tons of vanadium. So this, I would like to add this one. And thank you so much, Dr. Dora.
May I reply your first if I am not wrong? Okay, sir. Maybe, sir, nice. If that nice contains, whether that is nice or a magnetite ilmenite bearing granite, that need to be. If any hydrothermal fluid is connected with concealed mafic sources, then during this hydrothermal fluid, a deposit can be formed of a granite or even on any rock.
Okay. This is in the granite, the laterite we got it. Laterite.
But lateritation, sir, now it is a lateritized.
Yes.
You know,
Yes,
but that must have connected with some protoliths of mafics which not exposed, which might be concealed. Only the hydrothermal fluid which is connecting, and later it is subsequently means formed a lateritization.
Okay.
Or you are now getting as a laterite deposit types.
Thank you.
So,
After long time.
sir, I am seeing so many questions now cropping up in the chat box. I don't know how much.
No, what we can do is we'll send this question to Professor Dora.
Dora, yes.
Maybe you can, and you can take a couple of questions now.
I will take very.
Sir, I can take, sir.
Acha, same thing about BK Prushti. Professor BK Prushti is asking about the V can be found in coal fly ash. What should be the good concentration so that it can be commercially recovered? I don't know that he is asking how much minimum is required concentration of V so that it can be commercially recovered in fly ash.
These all are, sir, burning issues, and
yes,
we need to do experimentation first. How much, sir, cost is incurring during the mineral processing year? Accordingly, we do to back calculate, sir. Even it is a new for all of us.
And BM Farooq Saab is asking something away from this one in the sense that is the snowball earth. That means he is asking the 2.7 G Thalia conglomerate in Karnataka interpreted as a glacial-marine deposit. Though it doesn't belong to snowball earth, but being glacial-marine, do you think that it can be looked into for vanadium? It was anaxic period followed by great oxidation era.
That time oxygen was oxygen was too less in the marine system.
2.7 was not
in Archean, sir, vanadium is a very means very less. Only in Paleoproterozoic it is expected.
Yes, Professor Ramanath Professor is want to know whether any study has been carried out with respect to vanadium in the magnetite present in Bowl and Vasai belt. Same thing, sir. I don't know whether vanadium analysis and all these things, it is just being taken up. We are targeting rather palladium than the vanadium. Is not it? In the magnetite. So the hydrothermal palladium, PD we are searching, not vanadium. These are all recent things happening. So I think that the GSI and other people will be exploring agencies, they will be taking up, as well as the academicians, they will gradually focus more on the magnetite deposits in the layered complexes. Let's see
Sir.
how things are going.
I think I will take up some questions from the YouTube.
Yes.
I think so. I think Rajiv Ranjan has appreciated. Our former DG Kutum Rao has also appreciated. Rajiv Ranjan is asking, in Betul area, it is with carbonaceous shell or graphite schist?
It is with graphite schist.
Okay. And J.K. Nanda sir has also appreciated, and Vivek Moria, and Mr. Raghunath Mishra is asking, is there any genetically linkage of graphite with vanadium has been attempted? And can we look for vanadium within the carb shell of Mangampeta, that is Kadapa Basin?
Obviously, sir. We should. I told sir, graphite, vanadium. They, in one sense, they are common. Vanadium, uranium, graphite. They are redox sensitive minerals. They redox change up the redox condition, whether it is a V3, V4, V5, and the depend upon the oxygen fugacity how it is available in the system. It is if it is a reducing to slowly, it is going towards moderate, or it is upgrading toward oxidizing environment. Then during that time, whatever material is there, sir, vanadium will precipitate. And carb shell is the nice one, because it will contain organic organic material to absorb the vanadium, even if oxide minerals are not there, even a silicate minerals also not there. That is a good. That need to be really good, sir. That need to be really good. Like a PG, we need to analyze samples in a CM scale. In a vanadium also, sir, though it is not like sedimentary limestone type deposit or like iron ore, whatever we'll analyze, it will give value. We have to do little bit experimentation. Which part gives the maximum values? Even in a laterization also.
Sir, there is one more question from KL Mundra. That is a very pertinent question he is asking. Do you feel 1000 ppm V2O5, not vanadium only, V2O5 as a byproduct of RE deposits is of any worth?
V2O5000 means V is around 600.
600, yes.
1.78 need to be multiplied, then it will come V25. When I forget, we get analysis always in V2O5 because that is in oxidized form. We analyze samples in V2O5, but we get value in the V. We get values are in V. That need to be, sir, in a V2O5 convert. But 1000 is means 600 ppm. 600 ppm of, sir, which, sir, in which area? Along with RE?
Some associated with some RE deposit, he is telling.
Yeah, it's can I elaborate?
Yes,
sir, please, sir. Please, sir.
It's actually Ambadonga deposit where we have estimated nearly 1.2 million ton of ReO. And it's associated nearly 800 to 1000 ppm vanadium oxide is available there. And it's only a small part. There is a large area of Ambadongar. GSA has also worked in 3 blocks. So that is why my question. We can beneficiate. It is in the raw rock, carbonatite.
Okay.
It is in carbonatite, but sir, it must be hosted in some oxide minerals. In a carbonate means must be some, maybe perovskite, maybe some perovskite.
It's mainly with magnetite, and vanadinite is also identified from this area.
Okay, then sir, if it is a like a, sir, huge resource is there, even if a grade is low, sir, we should attempt, sir. And because these all are, sir, it is now it's very difficult to say at deposit wise at what cutoff one should work for a carbonated hosted type or BTM type or a graphite hosted type or your hydrothermal type or lateral type. Some around we generally carry out means 2000 to 3000, anywhere in between is good enough. But as you are telling, V2O5 is 1000 means, sir, I assume B is around 600 ppm, but 600 ppm is too sub-economic.
There is Dora, one more question.
1 minute, Dr. Mahanti, 1 minute. He's actually, Medini Gogoi is asking, using ProTrace in XRF analysis, can it help in knowing vanadium concentration? And in XRD, what mineral phases should you look for to detect?
XRD, XRD, sir, XRD only we carry out the analysis of weathered sample. Mineral phases identification XRD, when rock is a phase, then petrography is the best one, followed by EPMA. XRD is not that. XRD, it is very difficult to, sir, exactly give it will give, though it is one of the best for a mineralogical characterization, but if rock is a fresh, then go better with sir petrography and what is the second, that first one is sir XRF analysis.
Yes.
He is,
Using
I mean, he is
ProTrace.
talking handheld XRF.
No, he is telling using ProTrace in XRF analysis, can it help in knowing vanadium concentration?
Maybe, but sir, I am not
Okay.
confident or not.
The last question from the YouTube is a young geologist from Odisha Mining Corporation, Rajdeep Behra. He is asking, sir, can you expect vanadium mineralization in banded magnetite formation? And what percentage is expected? And what percentage is expected from that?
Actually, magnetite is the common, but BIF condition, other conditions, parameters are there different. Oxygen fugacity condition and your reduction states of BTM and BIF, they are not common, sir. So we won't expect much vanadium in that BIF type of deposits. You won't expect, because your reduction condition won't allow much to vanadium enter in the system.
Okay. I think it is over to Dr. Mahanti. I think you can close it, sir.
No, just I am closing two more questions, very important questions. Abhishek Shukla from GSI, as you know, that from Karnataka, he is asking in Nuggieli schist belt, same magnetite, banded magnetite deposits, they are having vanadium around 1.38%. So he is asking, can all the gabbros of the greenstone belts should be searched for the associated magnetite and vanadium? I think so, actually, that's true.
Actually, sir, if all gabbro means, sir, if the gabbros are late magmatic crystallization and differentiation, if oxides and both ilmenite and magnetites saturation taken place, it's not necessary that all gabbro will contain magnetites.
That is true.
Not necessary, sir. If oxygen fugacity is not up to, if not up to moderate, if oxygen fugacity will be more, then sir vanadium will not come. Even oxygen, even you have seen, sir, almost all gabbros are not containing magnetites. If that is the case, almost in all gabbro, in other complexes also you use it to get vanadium, but that is the not case.
So
that's why it's told, sir.
Okay, I understand. I think that Shukla got the answer. And one question from Nagaland, he is asking, I would like to know on future perspective of prospecting of vanadium, should we go for Nagaland ophiolites? What is the prospect there? Apart from magnetite and spinel, are there other host minerals for B in the mapping ultramapping rocks, especially associated with the ophiolites?
Sir, in a ophiolite, sir, they occur in a super subduction zone. So, means subduction zone fluids are generally less with this TI as well as Fe. Though chromites are formed, they are lensodate of chromites, but they are not with magnetite. But only thing is that if any laterite is developed over this ophiolite chromite or something, that can be secondary enrichment can take place, and one should look for the secondary laterite type, not with the primary chromitite lensoids.
So the last question, then I will close because it's already 8 o'clock. The last question from Dr. Archisman Datta. Excellent presentation, sir. Any probable suggestion about the occurrence of vanadium in hydrothermally altered clays and its association with sulfur or fumaroles? The possible oxidation state? He's asking about present day situations.
If vanadium is there in the source or nearby, and this organic clay and these are the best place to adsorb, like the RE adsorbed in the granite they developed in South China. How this the granites that is a adsorption process. The same way, if in the system it is available, then it can adsorb. If it is not there in the system, how it will adsorb? If vanadium is there, present in the system, then it can be easily absorbed by this even in a modern days fumaroles and all these things, hydrothermal fluids. It should be present in the system, the hydrothermal fluid itself. Otherwise, that hydrothermal fluid must be connected with the some protolith where it is enriched with the vanadium.
Thank you, Professor Dora. I think that we should come to an end. There are lot many questions which will be communicated to you. Try to send the message, the answers, possible answers to.
Thank you everyone for giving me opportunity and to discuss whatever sir best I can at my end. And thank you. It is a learning process, great learning process. While I discussing with such an intellectual group of Sgat, it is a real thrilling and sir, it is a always learning process.
It's certainly an engrossing one, and your audience number even crossed 100 at one time. So it's a big applause to you for generating so much of interest among the people about a very minor element which you used to know that associated doesn't have any mineral actually. That is the very sort of a paradox. That vanadium never occurs as a mineral. Again, we are searching in different tectonic setting. That's a very big thing, and a lot of interest has been generated among the mind of the people, those who are in the job of critical minerals and its association and all. Thanks a lot. I now hand over to Jayendra sir for the final. Thank you.
No, once again I thank everyone and mostly Dr. M.L. Dora and the overwhelming participation, and both in the Zoom as well as YouTube, and the kind of questions and the clarification they wanted to know. The purpose is done. That's what for the SGAT for which we have started this, that sharing the expertise and dissemination of the knowledge. I think we have achieved that. And for that, we profusely thank Professor Dora, and we now call it an end. And maybe next time, the next subject would be there, we will be announcing that. So thank you all for your participation, and good night.
Good night.
Thank you,
Good night,
sir.
Dora.
Thank you, sir.
We'll be in touch.
Thank you.
We'll be
Namaskar,
in touch.
sir.
Thank you. Thank you. Namaskar.
Thank you,
Namaskar. We'll be in touch.
Yes, and then we'll be sharing all the appreciation given to Dora. I think we will send it to you. Thank you. Thank you.